Hello and welcome to my video. If you haven't seen my previous video about the quadratic function, please check the link on the top right corner or the link in the description. Today we are going to solve another quadratic function problem. Well, actually it is a quadratic equation problem since we will be dealing with roots of the quadratic equation. But I am going to use the graph of a quadratic function to solve this problem and try to show you why using the quadratic function can be so OP. So the problem says, determine the range of A so that this quadratic equation, x squared minus ax plus 5 minus a squared equals 0, has at least one real root that is less than 1. If you actually try to solve this problem without using the graph of the quadratic function, say using the quadratic formula, you will find that the process is quite lengthy and tedious. So we are going to use the graphical approach. Let the left-hand side of the equation be function fx. Then, if the equation fx equals 0 has at least one real root that is less than 1, then the parabola y equals fx touches the x-axis where x is less than 1. And there are three cases where that is possible, and these are three possible cases. In the first case, both roots are less than 1, and in the second case, one root is exactly 1 and the other root is less than 1, and in the last case, one root is actually greater than 1, but the other root is less than 1. Now let us investigate the individual cases. So the first case, where both roots are less than 1. In order for this to be true, three conditions must be satisfied. First, the equation must have real roots in the first place, hence the discriminant must be non-negative. So the discriminant is a squared minus 4 times 5 minus a squared, and this must be non-negative. So we have 5a squared minus 20 must be non-negative. So we have a squared minus 4 is non-negative. So we have this. So we have a is equal to or greater than 2, or a is equal to or less than minus 2. So we have this condition. Second, the value of the function at x equals 1 must be greater than 0. Therefore, we have 1 minus a plus 5 minus a squared is greater than 0. Which is a squared plus a minus 6 is less than 0. So we have a minus 2 times a plus 3 is less than 0. So therefore we have a is greater than minus 3 and less than 2. So we have this additional condition. And lastly, we have the condition related to the axis of the parabola. You see, in addition to these two conditions, we require one more condition. And that is, the axis of the parabola must be on the left of x equals 1. So we have axis condition. And from this equation, we can see that the axis is x equals a over 2. So therefore, we have a over 2 is less than 1. Therefore, a is less than 2. So we have this range. Now we have to find a common range between this, and this. So the common range between these three is a is greater than minus 3 and less than or equal to minus 2. And this is the possible range for a for case 1, where both roots are less than 1. Now let's move on to another case. And now for the second case, where one root is exactly 1 and the other root is less than 1. In this case, two conditions must be satisfied. First, the value of the function at x equals 1 must be 0. Therefore, we have 1 minus a plus 5 minus a squared equals 0. So a squared plus a minus 6 equals 0. So this is 0. Therefore, a equals minus 3 or a equals 2. So we have this condition. And second, the axis of the parabola must be on the left of x equals 1. Since the equation of axis is x equals a over 2, we have a over 2 less than 1. Therefore, we have a less than 2. So we have this condition. So now we have to find the common range between these two, and the common range is a equals minus 3. And this is the possible range or in this case, a value for a for case 2. Also, note that the discriminant condition, which we used in case 1, is redundant in this case, since that condition is automatically satisfied when f1 equals 0. So we don't have to investigate the discriminant condition here. Right now, the last case. Okay, so the third case is one root is greater than 1 and the other root is less than 1. Here, only one condition is required, and that is the value of the function at x equals 1 must be negative. So from this condition, we have 1 minus a plus 5 minus a square is negative. So now we have a square plus a minus 6 is positive, a minus 2, a plus 3 is positive. Therefore, we have a is greater than 2 or less than minus 3. And this is the possible range of a for case 3. Other conditions, such as sign of the discriminant and the position of the axis, are redundant. The discriminant condition is already met if f1 is negative, and the position of the axis does not matter. So we have found these ranges for each case. The possible range of a is either 1 or 2 or 3. Therefore, a must be less than or equal to minus 2, or a must be greater than 2. And this is our final answer. So we have already found the answer, but here, let's plot our function using the Desmos graphing calculator and change the values of a to check the roots visually. As we change the values of a, you can see that the roots, the intersection points with the x-axis, indeed change. Now let us take a closer look. First, when a is less than minus 3, you can see that only one root is less than 1. Then, when a becomes exactly minus 3, then the greater root becomes 1. Next, when a is in between minus 3 and minus 2, then the quadratic equation has two distinct roots less than 1. And when a becomes exactly minus 2, then the two roots become 1, which is repeated root, but this one root is still less than 1. Actually, this repeated root is x equals minus 1. When x is greater than minus 2 but less than 2, the equation has no real roots since the parabola never touches the x-axis. So this interval is invalid interval for a. And when a becomes exactly 2, the parabola touches the x-axis again. So we have repeated root. But this time the repeated root is x equals 1. So therefore a equals 2 is also invalid value. And finally, when a is greater than 2, there are two distinct roots again, and one root is less than 1. Therefore, using the graphing calculator, we can visually check that our obtained range of a is indeed valid. And that's all for this video. I will upload one more video related to quadratic function in this week, so please keep eyes on my channel. You can also like this video and subscribe to support my channel. And as always, I will see you in another video.